Yes, good morning to all of you, all the students. So, welcome to the session of DMS. Am I audible and clear? And my screen is
Yes,
visible to all?
everything is okay.
Okay. Okay. So, in the last session, we have finished with your unit number one, which was an introductory session. So, in 2 3 minutes, quickly, I am revising everything that we have covered in the last session. And today, we are going to start your unit number two, which is ER model. So, in the first unit, let's quickly discuss what we have done. We have seen the definition of data, information, database, and database management system. And we have also learned the difference between data and information. Then we have seen various applications where we are using database management system, and we have seen at almost all the fields we are using DBMS. This is the most important slide of this unit. Why we are using DBMS and why not file processing system. And we have seen one by one what is the definition and of all these terminologies and why this is not possible in a file processing system and why this is possible in a DBMS. So the terminologies we have seen is data redundancy, which is duplication of the data, inconsistency, which is multiple copies of the same data, difficulty in accessing the data, data isolation, integrity problem. That means a database should follow some rules. If it is not followed, then it is integrity problem. Atomicity problem, when you are performing any transaction on the database, it should be completed fully or not at all. Concurrent access by multiple users, we have seen if multiple users are accessing the same data item at a time, then there may be possibility of data inconsistency and various security problems. Then we have seen the difference between instance and schema. Instance is nothing but the, you can say, screenshot of the database or current values of the database, and schema is nothing but the overall logical structure of the database. Then we have seen data independence. That means the details will not be visible to the below layer of any user. For example, as a user or viewer, you don't know what is the structure of the database, and middle layer, which is a conceptual layer, is not knowing physical organization of the database. So it is hidden from the current user. Any below layer details will not be available. So that is data independence. We have seen two types of architecture also, two-tier architecture and three-tier architecture. In two-tier architecture, what we have seen, the users, or you can say client application, can directly access the database. And we have also seen advantages of and disadvantages. Advantages are easy to maintain and communication is faster as you are directly accessing the database. And the disadvantage is when the application is bigger, means number of clients are huge, then the performance will not be up to the mark. And then we have seen the three-tier architecture, and there will be a one more layer, you can say, in between data and database and client application. We will call it as an application server, or you can say business layer. Various advantages are performance will be great in terms of bigger application, improve data integrity, improve security, and disadvantages, it is a little bit complex system. Then we have seen two types of languages. If we categorized database language, it will be categorized into the two categories: data definition language. Now I think we have laboratory first practical for all of the students. So the create table that you are doing in the lab, it is data definition language, because you are creating something, you are creating the database. That means you are defining it. Second is data manipulation language. The query you are doing, select query and all these things, is nothing but data manipulation language. And we have also seen procedural and non-procedural. DML, SQL that we are using, it is a non-procedural thing. Models that we have also seen, we will be mainly working with relational model, which is nothing but a tabular model. And the next chapter that I'm going to start is this entity relationship model, which is nothing but a logical or graphical design of any database. And last topic, we have seen various category of the user. Navy user is nothing but a new or untrained user, like university clerk. Application programmers who make application programs along with the database. Sophisticated user who are just specialized database administrators, database architectures, and specialized users who work with specialized database like you can say expert system or graphic data, audio data, environment modeling system, etc. And last, we have seen database administrator. What are the various tasks of a database administrator, and routine maintenance, and what is the roles and responsibilities of database administrator. So in the unit number 1, we have seen these many topics. So do you have any queries in the unit number 1? Any topic that you are not understanding? Anyone, any students? If you do have any query, you can let me know right now. Okay, so I think you don't have any query. So let us start your unit number 2, which is entity relationship model. Right? See, in simple words, in the C programs, what you are doing, I don't know whether you are practicing it or not. But when you are making a huge program, see, I'm not talking about the programs of 2 lines by adding the 2 number or finding the prime number or odd and even number. These all are small programs, that's 50 or 20 lines program. But when you are designing a huge applications, huge, very complex software, complex application, right? At that time, it is not advisable to directly start building the application and the database. Let me give you some real life examples. Consider this Marwadi University building. We will take the non-IT example, then I'll tell you to the IT examples. Consider we want to construct this building like Marwadi University building. What do you think? They have directly started the building, means directly construction they have started, or there are some phases? Can anyone tell me when we want to, you can say, build anything? Famous example of, for example, Burj Khalifa of Dubai, right? The huge building. So what do you think? Directly they have started construction, let's construct the building and let's build it. Or what do you think? What are your views? Can anyone tell me? Yes, designing model first. No, they have first drawn the architectural design. Yes, very good. Plan from base. Very good. Very good. Good. Yes. So whenever, see, you are designing anything or we want to construct or build anything, right? At that time, what people will do, they will first make the sketch, or you can say plan on the paper, And once they are okay, then they can start the building, or you can say any product. Consider the people have started to build this Marwadi University building, and then after the building is half constructed, then they have realized we have not we forgot to plan, for example, common room, boys common room and girls common room. Now they have already constructed half of the building. Now it is very difficult to accommodate now these new things which is forgotten, right? Now consider this building is fully constructed, then they have realized we forgot to build a computer lab or seminar hall, right? So it is very difficult then to change, because either you need to destroy this construction, right? So if people will directly start to build anything, then it will be very difficult. In your C also, right? What is the meaning of flowcharts and algorithms? Flowchart means a graphical representation of your program. So the ideal methodology is to first draw the flowchart and then start the program. See, I am telling you, I am not talking about the small applications. I am talking about complex application where thousands and thousands lines of programs are involved, right? Now when we come to the IT, see, you all are using this our Marwadi University portal, right? So what do you think? They have directly started building this software or building the database for the software? No. First, they have done some analysis part, some designing part, and pen and paper. And then once it is okay, when they have realized now we have included every requirement in this design, and then they will start building it. So this is the brief about the importance of designing, right? Anything, planning is very important. See, in small thing we all are planning. For example, when you want to go for outing also, some picnic also, then also we plan, right? When we will book the tickets, how we will go, what we will be carrying, where we will stay, planning phase, right? Then we will start actual implementation. So this is the thing about planning. So ER model is nothing but, you can say, a graphical representation of your data model, or you can say database. So generally what designers will do, the designer will construct the ER model. They will see that everything is covered or not, every requirement is satisfied or not, and then it will start to build the actual database, because the database is again as equal as building any physical product. If you make mistake, then it will be very difficult to, you can say, rectify that mistake. And I am talking about application where there are hundreds of tables are available in your laboratory. You are just you can say creating 3 4 5 tables, but the complex software, they are involving 50 80 100 200 tables. So you consider the complexity of database, where data is being stored, where data is going, from where you are fetching the data. So all these are complex things. So if you start directly building the database, then it will be a problem. So this is a base of entity relationship model, where people are first, you can say, creating a design of the database using ER model, and then they are, you can say, starting building the database. Clear this? Why or what is the need of this one? Any doubt? What is the need of design, or why we are using the ER model? Okay, good. So let us start this particular unit. Just a minute, give me a minute. Yeah, sorry for the delay. So this is the overall design process. Means what is the meaning of design? Why, if I am talking you the design of the database, it involves a design of the database schema. Now schema you all are knowing, logical structure of the database, and you all have created one simple table account in your laboratory. So design will involve database schema, design of the programs to access and update the data, and design of the security scheme to access the data. So when I'm telling you the design, it is not only creating the table, that's it. No. Designing program to access the database. Now you all are knowing select and all. As this was the first lab, we only seen very basic queries. But now when the things will go ahead, we will be learning some complex queries. So design will involve data design, data access, and data security. Second line, which is written in the PPT, is very important. Need of the users play a central role in the design process. Need of the user. See, for whom you are making the software, for some client. Yeah, whenever you will go, you will work in a company, you will be making the software for some clients. Now, what are the needs of the client? Right? For example, some school owner of the school will come to you. I want to make software for my school. Now that user is totally non-technical user. That user is totally non-technical user. They are not knowing what is database and all, what is software. And now it is your role to ask various questions to the what are your requirements, sir? How you are going to perform, what is the various operation, what are the various department in your school, are you taking online fee or offline fee, are you right now are you taking online attendance or offline attendance, everything you need to ask small question, and then you need to convert these requirement of the user to the software. You need to make the database and the software in such a way that you satisfy the requirements of the user. So need of the user, what user wants, what client wants, is the very important. And the third line, which is written, direct design process is difficult for real world application since they are highly complex. I already seen directly design process is very difficult. Now design alternative. Design alternative means what mistake we can do or we will do while we are designing the database. One is redundancy and second one is incompleteness. Now let me explain these two design alternatives with one example. Again, let me open the Excel. Consider I am making a database for a college where I want to store which students are studying which subject. There is a huge database, but one part of the database is which student is studying which subject, right? So let me, for example, I am making database like suppose enrollment number, student name, subject code, subject name and credit. So I want to store the data of like this: enrollment number, student name, code of the subject, name of the subject, and credit. Now, for example, enrollment number 1. For example, student name is Hassan. Subject, for example, every students are studying 4 subjects. So, for example, CE 101, CE 102, CE 103, CE 104. For example, subjects are data structure, maths, database management system, and data communication network. And credit, for example, 3, 4, 5, 4. These are the credit. And same thing is this. Now, what is this? Ali, can you unmute yourself? Can you mute yourself, Ali? Otherwise, I have to remove you. Right. So this is student number 1. Now student number 2. For example, Ali. Same. Yes. Now Ali is also studying same subject. Now third student. For example, Krunal. Krunal is studying same subject. Now, for example, Amit. Amit is studying same subject. Like this, the class is having students, and 60 student list. So this is the design. Now tell me, is this a proper design? Is this a good design? Or if yes, then why? And if no, then why? Let me show you again. Is this a good design? Any answer from anyone? Is it a good design or not?
No, it's not, I think.
It's not. No, yes. The data is repeating again and again. Very good. You see, there is a lots of data redundancy. Name is repeating, subject codes are repeating, subject names are repeating, and credit is repeating. So can anyone suggest me a better design than this? But you need to take care the information should not lost. What do I mean information should not lost? That means I should have the information which student is studying which subject. This is what I want. This is what I want. Can anyone tell me how can we make better? No, it's not. Maybe we can make the subject's name frozen and name are the information we full. I don't know, Rani, what you are trying to tell, but let me show you. This is the design. Now, can anyone do anything so that I can somehow remove data redundancy and my information is also not lost, because I also want to know which student is studying which subject. You observe this and let me know. I'm giving you 1 minute. So in 1 minute, you observe this and let me know. Okay, I am getting too many replies. Write subject name as a row or grouping of the data. See, we cannot store multiple values in the same field. You might have studied in the laboratory. You all have created the table, right? You cannot store two values in the same field. A field should contain a single value. Make column for subjects. Or by giving some unique identification number to each student. See, each student we have already given unique identification number. We list the student name only because other data subjects codes are fixed, but we also want the information that which student is studying which subject. See, there right now there are many solutions possible, and we will be learning these in subsequent chapters when we learn normalization of the table. But one small solution we can do, see, for each student, Hassan, Ali, Krunal, Amit, subject code and subject name are repeating. Subject code and subject name are repeating. Even credits are also repeating. So rather than this, what I can do, I can have one more table. I will decompose this table into the two table. I will divide this table into the two table. So now in one table, I will write this. I'm writing here. One table, I will write this. Because, who is this? See, don't unmute yourself, otherwise I will have to remove you. So one information is this. Now, if you see in these, now I am having the information that which student is studying which subject. Hassan is studying this, Ali is studying this, Krunal is studying this, Amit is studying this. But the information which I lost is what is the name of the subject and credit of the subject. What is the name of the subject and credit of the subjects. So what I can do, I can make one more table where I will write subject code, subject name and credit like this. Now, what I can do, I can write this. Simple. So now, what I have done, see, in this table, this is the table number 1, this is the table number 2. So now, same thing I have done, but I have divided the table into the 2 parts. Now you can see subject name is repeating only one time. Subject name, here you can see subject names are being repeated for every student. But now only code, because see, we cannot remove the code and student name, or we cannot write it one time, because otherwise we will not know what student will study. So this is essential. But now what we have done, so from here Hassan is studying CE001. Now if you want to know what is CE001, you can refer the second table. CE101 is data structure and credit 3. Now for example, Krunal is learning CE103. So if you want to know what is CE103, so you can refer the second table, which is DBMS and credit number 5. So we have removed, see, I am not telling you I have 100% removed the redundancy, right? But these, rather than having this design is better, because now subject code and credits are only written one time, not multiple time. So this is the design alternative. Rather than having this design, you can have this design, which is better. So whenever you want or you are designing such database, you need to take care regarding all such issues. And as I have told you, once you will design the ER diagram, ER model, all these will come into your mind. So this is first one. Now second is incompleteness. Incompleteness. Now what is incompleteness? Now again consider this table. You forget this. You consider this table. Now I have introduced one new subject. For example, this is third semester subject, and I have introduced one new subject, but I have yet not offered it. I have yet not offered it to the student. I am planning to offer in the next year. I have made one new subject. For example, I want to offer Python to the third semester student, but I have not offered it right now. So can I enter it into the database? For example, if I write, for example, CE105 Python, and credit, for example, is 5. I have introduced these new subject, but I have yet not offered it. That means no student is learning the Python. So this is blank. This is blank. And in database language, we will call this as a null value. What is null? I will tell you in the detail in the next lecture, but this is very bad design. When your data is having null value, null is nothing, no value, 0, blank, not 0, blank. When you are having such design, this you can say your incompleteness, your database is incomplete, it is having null value, but you consider this. Now in this design, I can do the same. I have introduced Python and I can write over here, because I am having student table separate and I am having subject table separate, right? So same thing, if I will follow this design, I don't have any problem. One more problem in this. Can anyone tell me one more problem in this design? Any observation? Two problem I told. One is data redundancy and one data incompleteness. One more problem. Any answer in this design? This design. One more problem. Very good. Integrity. Ravi, how can you explain? Yes, tell me, Ravi, how it will be integrity problem? No, Ravi. Anyone? Other than what is the, let me show you the Excel again. So this is data redundancy. We have seen one more problem. When there is a redundancy, what is the other problem that may come? Consider that important slide. First line, data redundancy, and what was the second word? Very good, Neeraj. Have to update multiple data. That is data inconsistency. Consider I have changed the credit of data structure. I have changed the credit of data structure, which is from 3 to 4. So I will have to change at multiple places. For example, here, then again data structure 3 to 4 here. Again data structure 3 to 4 here. And consider I forgot to change here. I forgot to change here. So for Hassan, Ali and Krunal are studying data structure with 4 credit and Amit is studying data structure with 3 credits. So what is this? Multiple copies of same data inconsistency, but in this design where I just need to store change over here at only one place. I will make here from 3 to 4. So here I need to only change at one place, but here I need to change at multiple place because data redundancy. So there are various problems which I have discussed with this design. So this design is not proper. This is something better. Understood, everyone? Any doubt, any query up till now? Anyone? See, all these are very basics and very important. Clear, very good. At least there are 64 students are attending right now, and I am getting a response from 10 students only. What other 54 students are doing? Sleeping? At least you can say yes or no. It is free of cost. You need not to pay anything in saying yes and no. Very good. So let's move ahead. So now we are starting entity relationship model. See, our ultimate goal is to make ER diagram, right? So now to make ER diagram, you need to know what is entity, what is relationship, what is attribute, types of attributes, various constraints, these many things that you need to know. Then you can actually start the ER diagram. First, we will be studying all these things, and then we will be starting actual ER diagram. So let's see what is entity. Enterprise schema that represent the overall logical structure of the database. So this is the definition of ER model. Enterprise schema you all know now. It is logical design of the database that represent overall logical structure of the database, because we are not actually making it, but we are just making the design. It is very useful in mapping the meanings of and the interaction of the real world enterprise into conceptual schema. See, whenever you are making a software right now, just before some time, we have taken example of a school. Now that school owner will not tell you their requirement in the technical terms. What the school owner will tell you, I want to have free online. I want to know who student have who have paid the fee and who have not paid the fee. I want attendance online. I want each and every detail of the student. I was mentoring online. I want timetable online. Right? So they will tell you the requirement in the non-technical form. I want teachers of the detail online. Right? I want to add this in my software. I want to add that in my software. Now, all these are non-technical requirements. Now, as a database designer, it is your role to convert or to, you can say, specify this design into the technical requirements or conceptual schema. So for this, ER model is the useful. Now in ER model, there are two terms, entity and relationship. So here we will learn what is entity and entity set, what is relationship and relationship set, and what are the attributes. In simple term, entity sets is nothing but your table and attribute is nothing but your column. This is very simple. Let me clear it. Entity sets is nothing but the table which you are making. Table we will call in the relationship, or you can say relational database model, and attribute is column. Column we will call it as a relational data model. Here we will call as a attribute. Now let's see what is entity set. An entity is a thing or object in the real world that is distinguishable from all other objects. Let me repeat, entity is a thing or any object in the real world that is different from all other objects. So whatever you find which is different than each other object is an entity. For example, each person in the university is entity. So let me tell you 10 names. Tube light, fan, AC, table, water bottle, classroom, projector, chairs, tables, computers, telephone, pen, mobile, laptop. Each of these things are different than other thing. So anything in the real world which is different than the other thing is called entity. An entity has a set of properties. We will call these as a attributes. So every entity is having some properties, and the values for some set of properties may uniquely identify the entity. For example, person may have person ID. So let us talk now in the chat. Tell me what are the properties of a person. A person is an entity. If you want to have properties of a person, what you should have as an attribute? What is the attribute of a person? Tell me. Fingerprint, height, weight, gender, eye. No. See, in eyes, what you will write? Behavior. See, generally attribute will come like person ID, person name, height, weight, phone number, address, email ID, some, for example, driving license number, Aadhaar card number, passport number, something like that, right? What are the attributes of a fan? For example, fan. Fan is an also entity, right? What are the attributes of a fan? Blade, brand, RPS, capacitor value, speed, then brand, company, model, serial number, something like that. Color, very good. Now one last example. What are the attributes of a chair? There is a chair. What are the attributes of a chair? Wood type, color, movable, size, weight, types of legs, height, wheels, number of wheels, something like that. Now you can understand, see, now we have taken 2-3 example, fan, chair, person. So each entity are different and each entity are having different attributes, and each attribute is also having different value, right? For example, take a person. So height, for example, 6.1, weight 80 kg, ID, for example, 001, name, for example, Ahmad, then some number, some color, then address, something like that. So each are having value. So like fan, for example, Orient, brand is Orient, then number of blades are 3, color is white. So each attribute is having some value. So entity is anything which is different from the other real world entity, and entities are having some attribute. Sorry. Now, an entity may be concrete, such as person or book, or it may be abstract, such as course or course offering or a flight reservation. Now, there are two types of entity. One is concrete, the entity that you can touch. The entities that we have just discussed is the concrete entity, that are the physical entity that you can touch, right? Like fan, chair, AC, laptop, person, book. But the entities that there are some entities which are abstract that you cannot touch. For example, course, subject. Can you touch the subject? No. It is an abstract. Course offering, right? Reservation, flight reservation. It is nothing but some abstract entity that you cannot touch. So concrete entity you can touch, and the abstract entity that you cannot touch, or you can say logical. So entity, understood everyone what is entity? Okay. Now next is entity set. Next is entity set. An entity set is a set of entities of same type that share the same property or same attribute. Very simple. Same type of entity, when it will come together, which are having the same attribute, it is called entity set. For example, entity set of student might represent the set of all students in the university, right? Fan, set of all fans in the university. Laptop, set of all laptops available in the university. And books, set of all books in the library, right? Now entity set means similar type of entity that will be stored together. Now book entity cannot have fan, because book is having different attribute, fan is having different attribute, table is having different attribute, and chair is having different attribute. So similar type of entity who share the same attribute is called entity set. An entity is represented by sets of attributes, and attributes are descriptive properties possessed by each member of an entity set, and each entity has value for its attribute. Like book, for example, a book. Book. What are the attributes of book? ISBN number, serial number, title, author's name, number of pages, domain, from which domain book, and all these are having value. For example, book's name is database management system, number of pages are 500, something like that. So each attributes are having some value. So entity is a single thing, a single object, and set of same similar object are called entity sets. So see, these are the various entity sets. Left hand side, you can view instructor. Instructor means teacher. So one is instructor ID and teacher name. So Craig, Katz, Srinivasan, Kim, Singh, Einstein, all are the teachers, instructor. So it is a set of instructor. So Craig is an entity, Katz is an entity, Srinivasan entity, Kim, Singh, because these are individual instructor. And the entire, that means collection of all the instructor is entity set, right? In right hand side also, Tanaka, Shankar, Zhang, Brown, Oy, Chavez, Peltier, all these are individual student. So individual, they are an entity, and together they are an entity set. So set of student, set of instructor are entity sets. So we'll keep up to this entity sets. In next lecture, we'll start with relationship set. So when you come to the next lecture, you should come with all these things. What is entity set, what is relationship set, and all. Up till now, any doubt? Any query? Okay. So you can write your enrollment number over here and then you can leave. Thank you. You can write your enrollment number and then you can leave.
Sir.
Yes.
Sir, you didn't update your this PPTs.
See, your voice is breaking. Can you type it? You can unmute yourself and you can type it.
Excuse me, sir, for the class invitation. Can you send it again or not? Because I didn't receive it for the first time.
Again, your voice is breaking, so better you type it. Students who have written the enrollment number are free to leave. They can leave the meeting. So let first all start the enrollment number, write enrollment number, then you can write your query. Let all write the enrollment number first. Okay, everyone have written the enrollment number, so I am stop recording. So now whoever will write the enrollment number will not be recorded.